You know what? Let me go over one example, and then you can go ahead and go, because the second one, they'll work on it. So on the example number 4, it says write an equation in point slow form. So this is nice because it's in point slow form. We're just going to leave it as y equals m parentheses x minus h and then plus k. That's the point slow form that we're going to be using of the perpendicular bisector of the segment with the given endpoints. So step 1. So the first thing you got to do is find the midpoint. Okay, so to find the midpoint, we label the points x1, y1, x2, y2. So for the midpoint, so on the midpoint, all we have to do, let me see over here, it's x1 plus x2, which is 6 plus 0, and then you get half of that. And then you add the y's, which is negative 3 plus 5, y sub 1 plus y sub 2, and then divided by 2. You always get half of that, yes. So 6 plus 0 is 6 divided by 2. That would be 3. What is negative 3 plus 5? That would be 2. And then divided by 2. And that would be 1. Okay, so we got the midpoint. And step 2, we need to find the slope. Find the slope. So here, by the way, the midpoint is capital M, and the slope is a small m. Okay, so the midpoint, and then the slope. The slope, the formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what is a y sub 2? Right, y2, which is 5, that is right, minus y sub 1, so it's plus 3, and then x sub 2, which is 0 minus x sub 1, and that would be 6. When you simplify this, 5 plus 3 is 8 over negative 6. And then when you simplify that, since you have a positive and a negative, the answer is negative, so put the negative in the middle. Can you reduce 8 and 6 by a number? By 2, and that would be 4 over 3. So the slope of those 2 points is negative 4/3. Okay, what I'm going to do is I'm going to do a little sketch of how that looks. 6, negative 3. I have 6 here. Negative 3. This is point A. Point B is 0, 5. And the point that we found, which is the midpoint, is 3, 1. See, that's the midpoint. Does it look like reasonable? Halfway? It does, right? And now, the slope of those 2 points, it seems like it's 4 and then 3. 4 and then 3. And that makes sense also, okay? So now, what I need is an equation of the perpendicular bisector, which is a line that goes in a perpendicular way, passes through that point. So to get that equation, I need to put the slope and the midpoint, but I need the slope of the perpendicular line. So what should be the slope that I need to use here? 3 over 4 is the negative reciprocal of the slope of those two endpoints. So I'm going to be using the slope of the perpendicular line and the point 3, 1. And 3, 1 would be my h and my k. So once you have those two pieces of information, all you got to do is put it into the equation. Y equals the slope, which is 3/4, parentheses, x minus h, and h is 3 plus k, and this is the answer. That is the equation of the line in point-slope form. Notice that here they don't want the equation in slope-intercept form, which is mx plus b. Otherwise, you would have to distribute the slope and then simplify a little more. But in this case, we just leave it like that. Any questions about example number 4? No? Okay, well, let me give you a chance to work in problem number 5, and then we'll check that, okay? What we have here, this is supposed to be the step 3. Okay, so if you were to label, there are 3 steps. And in this case, step 3, you stop here. And if they were to ask you to simplify in y equals mx plus b, then you continue to step 4, where you simplify. But here, we just stop in step 3, and that's it that you got to do, okay? You guys check your answer. This is Joseph Moreno's problem. First thing he did was find the midpoint. Did you get -1.5 for the midpoint? Yes, and then the slope. For the slope, let me just go ahead and label. This is capital M for midpoint, and this is a small m for the slope. So the slope he has is 2/3, and the negative reciprocal, it's -3/2. So you just put in the slope, -3/2, and it's x minus -1, so it's +1 and then +5. So that's the equation of the perpendicular bisector. Any questions about how to get the equation of the perpendicular bisector? So far so good? Okay, so go ahead and finish up. You have the worksheet that you picked up when you came in. If you have that completed by today, you get the 10 extra points. And that way you have no homework. And something that I need to tell you is that the glossary package for geometry, it's a quiz grade. Finish up pages 8 through 11. And that will be due, if you give it to me by Friday, see, the afternoons, I'm kind of like giving you a chance to have the afternoon off. If you finish up the glossary by Friday, you can get 5 extra points as a quiz grade. The package for geometry, right? That's a quiz grade. I don't have any more copies. I'm going to go ahead and scan the original, and I'm going to put it in Modo. If you need to make copies of that, well, by all means, make a copy of that, okay? And it's due the Monday when we come back from Thanksgiving break. But if you give it to me by Friday, you get the extra points, and you have no homework for the Thanksgiving break, okay?
So you're going to scan it? You can print it?
Right. I'm going to scan it, so if you need a copy because you don't have the other one, then print it out, and either Friday for 5 extra points or Monday when we come back is when it's due, okay? Okay, guys, so let's get to work on that. Okay, you guys, this is the second part of section 5.1, and on the second part, we're also talking about perpendicular bisectors. In this example, the one that you have from the notes from Monday on that worksheet, I told you that there's a part that I was going to skip for today, and that is this part here. It says you can write an equation of the perpendicular bisector of the segment. So today's objective is we're going to be able to write equations. And we're going to consider usually 2 points that form a segment. Okay, so in this case, the endpoints are -5, 6, and 1, 2. Since we have a segment and we want a perpendicular bisector, let me plot those 2 points so we can visualize what they're giving us. -5, 6. This is -5. So that point is about right here. And the second point, this is point Q. And I recommend that you do the same thing on your notes. On that worksheet that you have from yesterday, just put a little sketch on the side. The second point is 1, 2. So it's 1 to the right, 2 up. This is point R. Since I want a perpendicular bisector, Well, the perpendicular bisector cuts this segment in half. The perpendicular bisector is like a knife cutting this segment into two equal pieces, and it has to be perpendicular to this. So I need to know what the midpoint is, okay? So the first thing you need to do is you need to find the midpoint. So step one, find the midpoint. So you use a formula x sub 1 plus x sub 2 divided by 2, and then y sub 1 plus y sub 2 divided by 2. You label your points. This could be x1, y1. The second point is x2, y2. Then you substitute. When you substitute, this is x sub 1 plus x sub 2 divided by 2, and then is y sub 1 plus y sub 2 divided by 2. And then you simplify this. -5 plus 1 is, what is that? -4, and then -4 divided by 2. That is -2. And then 6 plus 2 is 8 divided by 2, and that is 4. So the midpoint is -2, 4. This is the midpoint right here. I'm going to put M as the midpoint. So I already found the point in between those two endpoints. Since I want an equation that passes through that point and perpendicular to the segment given, I need to know what the slope of QR is, okay? So I need to know what is the change of the y. So in this case, I'm at 6. From 6, and then this is a 2. So from 6 to 2 is, what's the difference? It's 4. So it's 4 down. And then I move to the right. So what's the difference from -5 to 1? That would be 6. There you go. So when you simplify, let me put here the slope is -4, 6, and then you simplify that slope, and that would be reduced by 2 is 2/3. So notice that they use a formula for the slope. On the example, it says step number 2, find the slope of the segment. And the slope was -2/3, and that's what we have here. They did it with the formula. I did it with the rise over the run. So you could do it either way. So -2/3 is the slope. Now, since I want a line that is a perpendicular bisector, well, since that's the slope of the perpendicular bisector would be the negative reciprocal of the -2/3. So what is the negative reciprocal of -2/3? 3/2. So the slope that I need to use is 3/2, and the point, the midpoint, is -2, 4. So now that I have the two pieces that I need to get the equation, let me move everything up here so that I can have some space. So now I need to get the equation of the line. So I have to use the point slope form. Y equals m parentheses x minus h, and then plus k. Yes.
Were you trying to were you trying to just turn it into a positive? That's why you switched them.
I'm trying to get the slope of the segment that is perpendicular to this segment here.
Okay.
And since the slope of this one is -2/3, -2/3, -2/3, -2/3, then the line of the perpendicular bisector should have the negative reciprocal of that. So that's why we switch it around and we change the sign. Now all I need to do is put the slope and put the point. Okay, so on the point, on the midpoint, that becomes the h and the k. And now all I have to do is just plug it into the equation. So when I plug it in is y equals, the slope I need to use is 3/2 x minus h, so it's negative times -2 is +2, and then plus k, which is 4. Now that I have that equation like that, I need to distribute. So when I distribute, it would be y equals 3/2 times x is just 3/2 x. What is 3/2 times 2? It would be 3. And then plus 4. So what is that equals to?
Y equals 3/2x plus 7.
3 plus 4 is 7, yes. Y equals 3/2 x plus 7. So this is the equation of the perpendicular bisector. Okay, and if I go to the graph, and if I plot those points here, I start at 7, which is going to be somewhere over here. That is a 7. And then I move 3 up, 2 to the right. But since there's no more space, I'm going to go to the opposite direction. So it would be 3 down. So 3 down, 1, 2, 3, and then 2 to the left, 1, 2. So I end up on that midpoint. I do it again, so it's 3 down, 1, 2, 3, and then 2 to the left, 1, 2. So that would be the point that I need to plot here. So I plot that point. And I can continue. See, I was over here at 4. So I'm at a 1 because I went 3 down and then 2 to the right. So I'm at a 1. And then I just connect those points. And that is a line that is a perpendicular bisector. And that is the second part of section 5.1. It's not only finding the distance or, the length of the, how much is it from the perpendicular bisector to the segment, but in this case it's finding the perpendicular bisector, which is finding the equation of the perpendicular bisector. Any questions on just this example, the one that was given on the paper? So far, so good? Okay, now let's go ahead and go to the